Yeah, hi everyone. I'll just reintroduce myself for the people who just joined and for the recording. My name is Shardul. I'm a solutions architect with AWS, focusing on the next gen developer experience. My involvement and kind of interest in Winglang existed before that, mostly because I believe that it is the future of cloud native. Like this is the right way to go about redefining the programming paradigm for a cloud native world. So I'm here for it. I'm here to help. I'm here to like enjoy the ride. As it comes to Cloud.stream, which I'm going to be talking about today, it's essentially just it was open as an issue, saying that hey, we don't have a well-defined RFC for streaming. So I have a little bit of interest and history in cloud streaming, so I went ahead and kind of took it on myself to build it out over time. The idea here is to make it as approachable as possible while still making it clear that this is not just a standard queuing system. Like that this is for massive real-time data ingestion and not for, oh, we get like 50 messages an hour or something. So typically streaming is used for real-time analytics, monitoring ETL of like real-time data, IoT systems, gaming if you want like in-game alerts and stuff. Oh, yeah, I'm gonna turn that off. There we go. And then often in e-commerce and essentially like personalization systems where essentially the algorithm is fed your real-time interaction data and can generate recommendations for you. As it comes to the cloud, this is implemented through AWS Kinesis, Google Cloud PubSub, Azure Event Hubs, and through open source solutions like Kafka, Pulsar, so on and so forth. I'm going to start sharing my screen just so we have kind of a grounded conversation about the RFC. Let's hope this works. Can you see my VS Code window? Nope. Okay. Okay, so stop that.
It's been a while since someone has said, "Can you see my screen?" and I couldn't see it. It's keeping me on my toes.
It's usually another click. You just have to do another click. You do share, get my screen, and then you come back, and it still waits you to choose what you want to share.
Yeah, but apparently I have blocked screen share, so that's good to.
Oh.
That's good to.
Yeah.
Okay,
can you share? You can probably share a tab if you're doing Chrome. Will that be enough?
I may have soft locked myself. Give me 1 second. I'm going to leave and rejoin. Continue the conversation without me. Sorry. But actually, no. Wait. All of this is on GitHub, so maybe I can just share the GitHub link, spark some conversation while I go and fix my computer. Where's the draft? Oh yeah, here we go. This is the state of the RFC right now. It's in chat, so if someone who's better than me at sharing screen wants to do that, please, you can do that, and I'll be right back.
Sounds good. Hi, Anantu and Elad. I gave a short intro where I said that today I thought that it's going to be shorter meeting, but then Marcio just told me that he's not joining as well. He can't join. So it will be even shorter because Hassan and Marcio both were supposed to be presenting, and they're not able to join. So we have Shardul. You have as many time as you need, as much time as you need.
You are muted.
We can see your screen. We can see a screensaver.
Yeah, it's just a wallpaper. Fantastic. Okay, does that worked? Great. Okay, I'm just gonna do it from GitHub, because this is not great. There we go. Share this. Oh, come on. I can't share a different tab.
I can share if you want the GitHub, if it helps.
Yeah, honestly, that'll help, because
Definitely.
doing it through Firefox is apparently a pain now. Oh, never mind. I got it, I think.
Let's see.
Allow? Yes. Yay!
Yay, yay, yay.
All right, so the way it stands right now, just as an open discussion, if someone has any ideas about it, we essentially want to abstract away the entire idea of setting stream properties, and so so yeah, all we ask the user is, hey, provide a data horizon, because that's fairly important when it comes to streaming, so that data is only stored up until a certain extent. That's the entire philosophy behind streaming data, that you have a data horizon, which means anything before that time is simply deleted and like not stored anymore. Extending that, you're not just going to keep the streaming data just sitting in a stream, so you want to process it somehow. So the idea is to also have the ability to import said stream into any kind of in-flight function, and then process events from that. Following me so far? This seems fair. And
I'm not sure I understand.
Yep.
Oh, okay. I didn't see because I'm not sure this is about sending the event, right? This is.
Right. That is about sending data, but right below that there's like fetch. Yeah. Sorry. It works both ways. The idea is it's just transparently interpreted on the wing side. And Chris had an excellent point that we should also have an on-event system, so that anytime a record's put in the data stream, essentially we kick off some kind of compute on it. So specifically for ETL systems, this is great. And that's pretty much the core API as I think of it right now. And I think this will be a great kind of V1 or a draft. And yeah, great. We have some points.
Go ahead, Eyal.
Yeah, go on.
So I'm looking at the API, and it's quite similar or even identical to the Cloud.q API.
Yes.
And I'm wondering, what does this mean? Is this? I mean, I can just implement the queue with Kafka, right? I mean, I can just. Is this I mean, this a functional? I mean, I know it's a functional thing. The stream versus the queue, as you kind of mentioned, it's a different type of traffic.
So theoretically, yes, but I think the reason why a separation might be necessary is the fundamental differences between a queue and a stream. A queue guarantees at least once delivery, and I mean most queues are like at most once. So you have a guarantee of deduplication, you have a guarantee of delivery. Whereas in a stream, the only guarantee is at least once. It's very difficult to guarantee at most once delivery. And beside that, obviously, the throughput is different. The internal way that the data is stored is massively different. So if you try to apply queue standards to streams, it doesn't work, purely because of the sharded nature and like the decentralized compute aspect of it.
Thanks. And sharding, we're not seeing sharding here at all. I'm not seeing kind of in Kafka.stream. I can basically kind of say that the events from the same sharding key should basically go to the same. And then I have instead of a Lambda function, I probably have a service that aggregates these events. So that's not visible in this.
Right. Yeah, it won't be visible here. That's kind of that. I'm putting that in the V2 of this just because the extension will be we add a dedicated stream data class, and then we can essentially abstract away some of that infrastructure metadata that's associated with streaming, shard ID, partition ID, so on and so forth, and we essentially pass that control down to the user as a, hey, extend this, define that as the partition key. So we'll manage the topics for you essentially. That's the long-term vision. Chris and I have a pretty comprehensive chat on that, so he's been helping a lot. Yeah.
Something tells me that the API needs to include some kind of sharding, partitioning. Again, I think that a good exercise is usually, and it sounds like you're doing that, but a good exercise is usually to go and see, okay, how is this going to be implemented for using Kinesis is using using Kafka, and basically see if we can actually map these systems, right? Like if we can actually create an API that can map to both of those systems. That's a pretty, it could be a big challenge, but I do think that, like, intuitively, I think like a partition key and some sharding properties or attributes, or alternatively, maybe a higher level, sometimes that's possible, to talk about how do you call it? The capacity of like how fast you want to process the stream, right? Like that's, in a sense, like that's why you would want to shard, because you say, I want to shard it because I want to process X amount of data per second or per minute, or so I think like maybe that's a higher level API that maybe we can offer, but I think that's the heart of this design in a way, right? Like, because this is why you would use streams as opposed to queues in a sense,
Exactly.
right?
Exactly. Yeah, and that's part of the kind of advanced usage right now. The kind of standard usage is just give us a data horizon so we can maintain it. It also has a default, so someone can just go new Cloud.stream and just forget about it. But this kind of this read, write, and horizon are the three things I want to focus on, and that obviously becomes a very complex calculation in the backend. Because Kinesis is a very specific way of representing read-write units, and they don't directly map to the Kafka equivalents, and none of them map to the Google PubSub and Event Hub's read-write systems. So all of that will, like, there'll have to be a complex calculation that goes into it, which it'll come down to experimentation.
Okay, I think that's going to be an interesting, that's going to be the heart of this.
The heart of the challenge.
Event. Yeah. But that's great, by the way. Nice to meet you, and thanks for doing this. This is amazing.
Yeah, of course. But yeah, the biggest challenge I'm really facing right now is designing the. Sorry, Yov, you have a question. I'll get to you in a second. The biggest challenge I'm facing right now is, in my vision, I want to simply abstract away the idea of managing the stream. And so the crux of the matter comes to, like, we define an in-flight struct that says, hey, this is the stream data that we care about, we the engineer care about, or we the customer care about. And all you have to do is just define that struct and forget about it. Managing it in the stream is all taken care of by the Wing kind of runtime. Or, well, there isn't really a Wing runtime, but like we generate the code to manage most of that, if not all of that. Yeah, and that's what I'm trying to work towards. So we while transparently we can expose partitioning and sharding, I say, hey, let's not do that. but let's take it up one level.
Okay. That's by the way, taking it up one level sometimes it's useful to actually create these things in layers, right?
Mm-hmm.
Like, so start with like something that's like a bit more mechanical and requires the user to understand the concept of sharding and partitioning, and then on top of that, build something that's higher level and smarter, because I'm sure there will be users that will be interested in like the lower level API in a way, and so you can think about it this way, like you might be able to actually build this in layers and have like a stream and then automatic stream or something like that,
Makes sense. No, it makes complete sense. Yeah, fully agreed. Yeah, Yov, am I pronouncing that right? Sorry.
Yeah, 1 second, because I have a child alert here, so I'll have to deal with that. So just continue. We'll see if I can get back to you.
I mean, I don't really have that much to continue on. The idea is the simulator will just mimic the sharding principle on device. So you'll only be bottlenecked by like your read-write speeds, and then the stuff that I'm focusing on first is implementing it in Kinesis. So that's gonna happen soon. TM.
Yeah.
Okay, so I'll try a few things. Well, first of all, this is great. I mean, the idea of having adding a stream feature, like it's great that you're trying to tackle this to the cloud library. I don't know much about streams, but I've been involved in Redis streams a bit, and two key features in Redis streams that are like very basic in the API are acknowledging, right? You get a batch of data, you process, and then you acknowledge it so no one else will get that data. So interesting to see if that makes sense, adding that to the API. And built-in timestamps where the data could be whatever structure, but in most cases in Redis, unless you kind of explicitly don't want that, you have timestamps on the stream data. I don't remember if it's like milliseconds but it is timed, which could be a nice feature to kind of standardize. But I'm not too familiar with other streaming, so I don't know if it makes sense. But in Redis, it's very basic, like acknowledging and timestamps, in addition to partitions and what we said before. Another thing is probably not relevant here, but it's this one other case of having like needing generics in our cloud, in our basic cloud libraries, right? Because making a stream of something would be cool, right? Because Q kind of begs for it, and this is another case. And I also kind of like the idea what you were talking about hiding the shards, hiding the mechanics of it. We have platforms, right? So we can. It'll be cool, not if we can achieve something without them. So those are like my thoughts up until now. Thanks.
Just response on the platforms note. It's important to remember that a platform needs to. We can't use platforms as a way to customize every application, right? Like we need to make sure that the platform implementation, especially the default ones, the ones that we ship with Wing, can work out of the box. And I don't have to like say, oh, well, actually I have a stream here, so I need to configure the platform to specify the partition key, right? Like that, this is exactly the boundary between the application and the platform. So I think it might be clear, but I just want to make sure that we're not abusing the fact that we have platforms. Oh yeah, this thing is the user will define it as part of the platform configuration. And
Yeah.
and by the way, Redis streams could also be a really cool way to, again, I think like having like a bunch of examples is a great way to like kind of like distill the common denominator, right? Like that's a very powerful design technique.
Yeah, absolutely, fully agree. And I didn't know Redis streams existed, but they look fascinating. And yeah, like content-based deduplication is just built into it. So that's do we consider that the standard? Is the next big question. No, yeah. Yeah. Any other comments? Any other like possible improvements? I'm here for it all, because this is all just coming from like reference architectures, what I've seen with customers and how they're using Kinesis, and essentially what their gripes are with it. Because a lot of the times they're just like, hey, this base64 encoding stuff, that's really annoying. We need to build separate transformers for that. So it was just like, I don't know, let's abstract it away. They don't need to look at it.
Yeah. No, this is going to be super cool.